Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the difference between the two algorithms that are the Prim's and the Dijkstra's algorithm, right? So logically these two algorithms are totally different, but the way of writing these two algorithms is totally same, right? So there is only a slight difference between the algorithms of these two, but logically these two algorithms are completely different. So let's discuss about the difference between these two, right? So Prim's algorithm is used to find the minimum spanning tree of a graph, right? So I hope you know what is a minimum spanning tree. So minimum spanning tree is the tree obtained from a graph such that all the vertices of the graph are also present in the tree, but with the minimum cost, right? So since this is a minimum spanning tree, so you have to convert your graph to a tree, but with the minimum cost such that all the vertices of graph are also present in the tree, right? So also the cycle, since this is a tree, so the cycles must not be present in the tree. In graph there should be cycle, there must be cycle present, but in the tree there should not be any cycle present, right? So Prim's algorithm is used to find the minimum spanning tree of a graph. On the other hand, Dijkstra's algorithm is used to find the shortest distance of the source to all the vertices of the graph, right? Dijkstra's algorithm is used to find the shortest distance of source to all the vertices of the graph, right? So these two algorithms are totally different. Dijkstra's algorithm does not work well for negative values. So if any of the negative value is present in your graph, then there is a high possibility that Dijkstra's algorithm is going to give you the wrong answer, right? But Prim's algorithm can work for a negative value as well, right? So these two are the major differences between the two algorithms. That is, Prim's algorithm will give you the minimum MST of your graph, but Dijkstra's algorithm will give you the shortest distance from the source to all the vertices of your graph, right? So sometimes there is a confusion that while finding the minimum spanning tree of a graph, you are able to find the shortest distance of source to all the vertices also, but this is not necessarily true, right? So let's take an example. Let's suppose your graph is like this, right? So the weights are 4, 5, 2, right? So if you apply Prim's algorithm to this graph, then it will give you the minimum spanning tree. So the minimum spanning tree of this graph will be this and this, right? Now the cost of this MST is what? 4 plus 2, 6, right? If you convert this like this, then the cost of this MST will be 9, right? So the cost is minimum in for this spanning tree. That's why this is the minimum spanning tree for this graph. On the other hand, while you apply Dijkstra's algorithm to this graph, then it will give you the result like this. Now you can see that these two results are totally different, right? So Dijkstra's algorithm will tell you the shortest distance. Here one is our source, right? So Dijkstra's algorithm will tell you the shortest distance to reach from source to all the vertices of the graph. Now shortest distance to reach from 2 from 1 is what? 4. Here the shortest distance to reach to 2 from 1 is what? 4. Here the shortest distance to reach 3 from 1 is what? 5. Here the shortest distance, here the distance to reach 3 from 1 is what? 6, right? So minimum spanning tree, Prim's algorithm is not going to give you the shortest distance, the result provided by the Dijkstra's algorithm always, right? So this is the major difference, right? So if you have a confusion that while finding the minimum spanning tree of a graph, you are able to find the shortest distance also from source to all the vertices, then you are wrong, since Prim's algorithm will only give you the MST, but not necessarily the shortest distance of source to all the vertices, right? Here you can see that it is giving you the distance to reach 3 from 1, it is giving you 6, but the actual shortest distance to reach to 3 from 1 is what? 5, right? So it is giving you the wrong answer. So here from this example you can see the difference that MST is not always contained. While finding the MST of a graph, you are not always going to find the shortest distance of source to all the vertices, right? So Prim's algorithm is used to find the MST of a graph. Dijkstra's algorithm is used to find the shortest distance of source to all the vertices, right? So if you are applying any of this, you will not get the answer of other one. If you are applying Dijkstra's algorithm to a graph, you are not necessarily going to get the MST also for the same graph, right? So if you are finding the MST of a graph using Prim's algorithm, you are not supposed to get the result for shortest distance of all the vertices from the source, right? So these two are totally different logically, right? But a confusion arises because the way of writing the algorithm for both these are exactly same. There is only a slight difference. In Dijkstra's algorithm, when adding to a priority queue, when you are removing a node, you are adding the weight, you are adding the new as to the weight of that node, right? While in Prim's algorithm, while removing a node, you are only adding the neighbor to the edge of that node, right? So these two are these slightly different in their algorithms. Rest the way of writing the algorithm is exactly same, right? But logically these two are totally different. Why? Because Prim's algorithm will give you the MST, and MST will not tell you the shortest distance to reach from source to all the vertices of your graph. In the same way, Dijkstra's algorithm is going to give you the shortest path of the source of all the vertices from the source, but it will not give you the MST of the same graph. Here you can in the example you can clearly see that Prim's algorithm is giving this result, that is the minimum spanning tree of this graph. Dijkstra's algorithm is giving you this result, that is the shortest, that is representing the shortest distance of all the vertices from the source, that is 1, right? So I hope you understand the difference between these two. So apply this any of these in accordance to the question given to you, right? So in order to apply any of these, you must be able to find the difference between these two, right? If you want to find the MST, then use Prim's algorithm. If you want to find the shortest path, then you have to use the Dijkstra's algorithm, right? So I hope I am able enough to explain the difference between the Prim's and the Dijkstra's algorithm to you. So if you like the content, then give a like to this video. Thank you for watching. We'll meet in the next video. Bye bye.